What if a hidden planet drifted nearby tomorrow morning? The sky would look normal for hours. Then the ocean would betray it first. That is where the real problem begins. No fireball, no obvious crash, just a quiet shift in gravity. A heavy world close enough would bend everything else. Tides would misread the moon. Clocks would feel slightly off. Maps would start disagreeing with the sky. We usually imagine planets as distant dots, but distance is only part of the story. Mass matters, speed matters, direction matters. A silent planet can rewrite motion without glowing once. That makes this stranger than any meteor. A meteor falls. A planet rearranges. The first clues would not come from the public. They would come from instruments. Satellites would drift from expected tracks. Astronomers would see predictions fail. Their models would stop matching reality. That mismatch would spread outward fast. Navigation depends on stable positions. When those positions wobble, errors multiply. A tiny nudge in orbit can matter later. A planet-sized mass leaves fingerprints everywhere. First in satellites, then in the moon, then in the sea itself. The first hour would feel ordinary. The second would not. Some tides would arrive early, some would arrive too high, others would miss their usual mark entirely. That sounds small. It is not. The oceans already respond to gravity twice daily. Add another major mass, and the timing becomes messy. Not instantly catastrophic, more dangerous than that. The sea would lurch instead of rise. A sudden surge reaches farther inland. Ports would shut first, then river mouths, then low cities would watch the horizon. Harbors built for routine tides would lose that routine overnight. Fishing patterns would shift within days. Coastal life depends on timing more than height, and the atmosphere would not stay calm. A nearby planet could slightly reshape pressure patterns. Jet streams would drift, storm tracks could bend. That means rain changes location before it changes headlines. Some regions dry out, others flood more often. Farmers would notice before most people do. Now imagine the planet beyond the moon. Not bright, not fiery, just there. If it reflected little light, most people would miss it. Telescopes would not. Infrared sensors could catch its heat. Radar might catch its shape. Repeated observations would expose the same truth. Something massive is moving where nothing was expected. That is when the question sharpens. How close is it? If it stayed far enough away, Earth might barely care. If it came closer, everything changes. The moon would feel the pull first. Its orbit would wobble. That wobble would alter tides everywhere. One hidden world would start rearranging coastal life. The second day would bring a stranger problem. People would see the same sky, but not the same positions. That would not be imagination. That would be geometry changing in real time. A hidden planet close to Earth would bend light a little. It would also expose dust and debris nearby. Telescopes might suddenly reveal moons, or rings, or fragments trailing behind it. If that happens, the planet is not alone. A system is worse than a body. Think about the scale. Earth feels enormous on the ground. In space, it is just one object among many. A nearby planet could be denser, colder, larger, darker, or wrapped in gas that hides its surface completely. The most unsettling part is not appearance. It is silence. A planet does not need to announce itself. Its gravity does the announcing. By the first full week, the consequences would spread. Scientists would rebuild orbital charts, moon models would need updates, satellite fleets would need corrections, Mars missions would require new calculations. Anything relying on stable trajectories becomes harder. Space agencies would enter a race, not to chase the planet, to avoid losing everything else. A hidden world nearby would create a second priority overnight. Tracking it would matter as much as tracking storms, possibly more. Meanwhile, the public would catch the smaller clues. Longer nights in some places, brighter tides, unexpected eclipses, a moving point in the sky that should not be there. False guesses would spread first, then better ones, then exact coordinates. But the deeper mystery would remain. Why was it hidden so long? Nearby planets are usually hard to miss. They reveal themselves through reflected sunlight or through the pull they exert. So if this one was overlooked, something unusual helped it. Maybe it traveled on an odd path. Maybe it was unusually dark. Maybe it spent years behind the sun from our angle. Or maybe it came from a direction we rarely scan. The solar system is not a flat postcard. It is a crowded, three-dimensional zone. Some blind spots are real. In 2016, astronomers seriously discussed a hypothetical distant giant planet. That idea survived because gravity leaves clues, even when light does not. Now imagine the opposite problem, a planet not far away, but missed. The closer it is, the harder that becomes, unless it hides against a bright background, or lives near the sun's glare, or moved in a path that changed recently. Each explanation feels possible. Each one is uncomfortable, because every answer suggests a gap in our map, not a failure, a gap. By the 10th day, the consequences stop being abstract. Fuel budgets change, flight windows change, power grids worry about storm load, coastal cities prepare for unusual high water. The planet itself might still be invisible to the naked eye. That makes it worse. People fear what they can see. They panic harder over what they cannot. Then comes the twist. A hidden planet close to Earth would not stay hidden for long. Not from gravity, not from infrared, not from the movement of everything around it. Once teams compare data, the orbit tells the story. They estimate mass, then distance, then path. If the orbit crosses Earth's neighborhood, the clock starts ticking. If it only passes near us, the danger shrinks. If it settles into a stable nearby path, the future changes completely. A second major world nearby would reshape astronomy itself. It would become the closest new frontier in history. Not a dot, a world. Maybe with mountains, maybe with ice, maybe with weather, maybe with signs of an ancient atmosphere. Every telescope would turn toward it. Every map would change. Students would learn the sky differently. The night would stop feeling empty. And that change would feel bigger than the object itself. The final clue would come from motion. A true hidden planet cannot move without leaving evidence. It tugs on dust. It alters passing objects. It leaves a trail in numbers long before it leaves a trail in light. So the first confirmed signal would probably be a math problem, then a telescope point, then a map correction, then a whole new section of sky with a name. That sequence has happened before. It could happen again. Earth orbits the Sun at about 30 kilometers per second. At that speed, every nearby mass matters. Even a slight nudge can stretch across millions of kilometers. That is why tiny deviations matter so much. They are how giant discoveries begin. And the strangest possibility is this. The hidden planet might not be new. It might be old. Older than our records. Older than our assumptions. It could have waited in the dark for millions of years. Or it could have wandered in recently. That difference changes everything. A long-time resident means our maps missed a stable neighbor. A newcomer means the solar system is still rearranging itself. Both answers are unsettling. The public would feel that shift in a strange way, not through immediate